Yes, me and Brendan are here to talk to you today about cognitive bias in machine learning. My name is Maureen Elaney. I work for IBM for the Center for Open Source Data and AI Technologies. I'm a developer advocate. You can get me on Twitter at mo_Mac.
And I'm Brendan from I also work at the Center for Open Source Data and AI Technologies. I'm not on Twitter, but you can definitely email me, brendan.dwyer@ibm.com.
And as I said, today we're going to talk to you about how bias can take root in machine learning algorithms and ways to overcome it. So machine learning algorithms make decisions like who gets a job interview, if your credit score or interest is raised, whether you get into a clinical trial, but there are also pretty dire social ramifications when it goes wrong. And I wanted to kind of define a term first because I don't want to assume that cognitive bias is something that everyone knows about. It's a pretty humanities-focused term. So basically, a cognitive bias is a deviation from rationality and judgment. Basically, you create your own reality based on your perception of things. And machine learning is not immune to this very human state. A cognitive bias in machine learning is the existence of irrational bias in the output of machine learning models. So all machine learning models, as we know, they're trained to discriminate. They're trained to decide for one thing against another based on how the algorithm is built. But all too often, AI is trained using biased data and thus reproduces inequality that exists in the real world. Recently, Congresswoman Alexia Ocasio-Cortez made a statement at a Martin Luther King Jr. rally event. She said, algorithms are still made by human beings, and those algorithms are still pegged to basic human assumptions. They're just automated assumptions, and if you don't fix the bias, then you're just automating the bias. Now, there's a lot of backlash in the media about these words, but I want to prove to you that this is a very real issue, and it's a bipartisan one that affects all of us, and it's worth fighting against. So if you saw my keynote yesterday morning, I only had time to share one example, and I kind of glossed over it a little bit. Today we're going to dive a little bit deeper into some more examples of bias in AI. So Brendan, we'll start.
So there's a lot of examples of bias in machine learning that we continue to see in the news. For example, in July 2016, Google announced the public beta of a new product called the Cloud Natural Language API. And what it does is it allows developers to incorporate Google's deep learning models into their own applications. The API includes a sentiment analyzer used to determine the degree to which sentences express a negative or positive sentiment on a scale of -1 to +1. Google declined to clarify how its API was trained, but the process generally works like this. A machine learning algorithm takes a corpus of text data labeled with positive and negative values, like movies or restaurant reviews. A positive score means the algorithm set a favorable sentiment, and a negative score means a statement is not desirable. In this example, I'm a Christian scores above 0, meaning it's a positive outcome, while I'm a dog scores 0, meaning it's a neutral outcome. Once it learns which words are associated with positive or negative scores, it can then bootstrap that data to learn about the associations of other texts by identifying which words are associated with positive or negative words. For example, if the word good is assigned a positive weight because it's associated with high movie scores, and the word translucent is likely found in a sentence with good, then translucent is assigned its own positive sentiment. The problem is that artificial intelligence systems like Google's Natural Language API will inevitably absorb the biases that plague the internet and human society more broadly. A quote by Ernest Davis, a professor of computer science at NYU, said, "It's easy to get around the biases for each individual problem, but getting around it systematically is very difficult." As Google's head of AI said at his company's conference, it's important that we be transparent about the training data that we are using and are looking for hidden biases in it. Otherwise, we are building biased systems. Google responded to this story and said they were addressing these specific cases. Google said, "We dedicated a lot of efforts to making sure the NLP API avoids bias, but we don't always get it right. This is an example of one of those times, and we are sorry. We take this seriously and are working on improving our models. We will correct this specific case, and more broadly, building more inclusive algorithms is critical to bringing the benefits of machine learning to everyone."
So another example of bias in AI, in 2008, the Broward County Sheriff's Office in Fort Lauderdale, Florida, decided that instead of building another jail, they would begin using a risk assessment score to identify which defendants had a less likeliness of reoffending and thus could either be released on bail or had a bail set pending trial. And the algorithm is called COMPAS. Since then, nearly everyone that's been booked into prison at Broward County Sheriff's Office has been set with a risk assessment score. And the executive director of community programs for the Broward County Sheriff's Office said that they chose the software over other tools because it was really easy to use and it produced really nice charts and graphs for judicial review. The software cost them about $22,000 a year to use. Now, ProPublica obtained the risk scores assigned to more than 7,000 people who were booked into jail in Broward County in 2013 and 2014, and they checked to see how many people who were charged with new crimes over the next 2 years after that. So they used the same benchmark that was used by the creators of the algorithm. Now, I'll be going through a few examples of people who committed similar crimes, but were affected by recidivism scores really differently. Now, a lower score means a less likeliness of reoffending and thus lower bail or less jail time, and a higher score means an alleged higher risk of reoffending, thus higher bail or more jail time. So in this example, Brisha Borden was rated as high risk for future crime after she and a friend stole a bicycle and a scooter from a kid's house. And it was valued at about $80. At the time, she was 18, and she didn't have a she did have a prior record, but it was just for misdemeanors when she was a minor. Now, Vernon Prater was the much more seasoned criminal here, but he shoplifted $80 worth of tools from a Home Depot store. And he had already been convicted of armed robbery and attempted armed robbery, for which he'd served 5 years in prison already. And then he had another armed robbery charge on top of that. Now, while Brisha did not go on to reoffend, Vernon is now serving another 8-year prison term for breaking into a warehouse and stealing thousands of dollars worth of stuff. Now here, Dylan Fugit, here on the left, he was rated as low risk after being arrested with cocaine and marijuana. He was arrested 3 times on drug charges after that. Gregory Lugo crashed his Lincoln Navigator into a Toyota Camry while he was drunk, and this was at least his 4th DUI, but he was given a low risk score. And James Ravelli stole from a CVS and then was caught with heroin in his car, but he had already spent 5 years in prison in Massachusetts before this crime, and he was rated as low risk. He then later shoplifted $1,000 worth of merchandise from Home Depot. So I'm going to show you 2 charts of the average risk scores assigned to criminal defendants based on their skin color. So here you see the average scores assigned to black defendants, and you can see that a fair amount of the people were given high risk scores on the chart. And this is the chart for white defendants. And you can see that the charts show the scores for white defendants were much more heavily skewed towards low risk categories, and the scores for black defendants were not. So in forecasting who would reoffend, the algorithm made mistakes with black and white defendants at roughly the same rate, but in very different ways. The formula was particularly likely to falsely flag black defendants as future criminals, wrongly labeling them this way at almost twice the rate of white defendants. White defendants were mislabeled as low risk more often than black defendants, and black defendants were 77% more likely to be pegged as a higher risk of future violent crime, and 45% more likely to be at risk of future crime of any kind. Now, North Point disputes these reports that were done by ProPublica, and the software continues to be used pretty widely across the country. But I should mention that North Point changed the name of their company since this report came out. They're now called Equivant. So you can take that to mean what you will. So due to algorithmic decision-making, populations that have historically been disproportionately targeted by law enforcement, especially low-income and minority communities, are slapped with high recidivism scores. And as a result, the algorithm amplifies and perpetuates embedded biases and generates even more bias-tainted data to feed a vicious cycle. There are many different risk assessment algorithms that are out there, like Compass, but most of them are proprietary, so there's no way to really hold them accountable or evaluate their decisions. At the Data for Black Lives conference in January, they talked about this problem in the criminal justice system quite a bit. And if you aren't familiar, the Data for Black Lives is a group of activists, mathematicians, and organizers who are committed to the mission of using data science to create concrete and measurable change in the lives of Black people. One quote from Rashida Richardson, who is the director of policy research at the AI Now Institute, really drove this home. She said, "In my experience, conversations around AI are, people talk about it like it's just a list of pros and cons. But that's a moment of power and privilege, to be able to determine that it's okay that some people are disproportionately harmed." So more than 100 civil rights and community-based organizations, including the ACLU and the NAACP, signed a statement urging against the use of risk assessment. At the same time, more and more jurisdictions and states, including the state of California, have adopted these risk scores as a Hail Mary effort to relieve their overburdened jails and prisons.
So now I'm going to talk about Amazon's facial surveillance technology that's currently the target of growing opposition nationwide. Reports indicate that Amazon sold their product called Recognition to law enforcement in at least 2 states and proposed the technology to Immigration and Customs Enforcement, and the FBI is now testing it. In a test the ACLU conducted of this facial recognition tool, the software incorrectly matched 28 members of Congress, identifying them as people who have been arrested for a crime. Using Recognition, they built a face database and search tool using 25,000 publicly available arrest photos. Then they searched the database against public photos of every current member of the House and Senate. I also want to note that they use the default match settings that Amazon suggests for Recognition. These false matches were disproportionately of people of color, including 6 members of the Congressional Black Caucus. Citing critical concerns over immigrant surveillance of vulnerable communities, racial profiling, and other civil and human rights violations, Amazon shareholders have filed a resolution asking the company to prohibit the sale of Recognition to government agencies. The shareholder resolution echoes concerns of over 70 civil rights and civil liberties groups, hundreds of Amazon's own employees, and 150,000 people who signed a petition, all seeking to end the sale of Recognition to government agencies. The group of shareholders who introduced the proposal represent a total of $1.32 billion of Amazon's market capitalization. On April 3rd, in a major victory for investors, the Securities and Exchange Commission ruled that Amazon must give shareholders an opportunity to vote on the 2 separate shareholder resolutions that address the major business risk posed by the sale of Amazon's facial recognition technologies to government agencies. The vote will take place coming up on March 22nd.
So Joy Buolamwini is a computer science and digital activist based at the MIT Media Lab. She founded the Algorithmic Justice League, an organization that looks to challenge bias in AI, especially with decision-making software. She ran the Gender Shades Project, which is her thesis project out of the MIT Media Lab, and she sought to see how well gender classification systems worked across different people's faces, and if the results changed based on someone's gender or skin type. She analyzed 3 companies, Microsoft, Face++, and IBM, our employer. And unfortunately, IBM had the largest gap in accuracy, with a difference of 34% in error rates between lighter males and darker females. Buolamwini said, "We have entered the age of automation overconfident yet underprepared. If we fail to make ethical and inclusive artificial intelligence, we risk losing gains in civil rights and gender equity under the guise of machine neutrality."
Thanks. Now the good part. How can we work towards fixing this? So first, I suggest you listen to this podcast, The Ezra Klein Show, where he interviews Anil Dash about the biases of tech. Anil Dash is the CEO of Glitch, on the board of Stack Overflow, and the nonprofit Data and Society Research Institute. One thing Anil said on the Ezra Klein podcast really stands out. Coders are the most empowered laborers that have ever existed. Yes, you have to meet deadlines and requirements, but you have the power to ask questions and prioritize the mitigation of bias from the onset of the development process. And there are tools out there to help you with ensuring that your algorithms are not biased. As a developer or data scientist, you are in the position of power to use these tools to ensure that the applications you build are fair and just.
So I think better education is also a really important solution to this problem. It's key to encouraging that more people consider the people who are affected by the algorithms that they're building. And we definitely need to recognize that the choices we make in building new technologies can have really dire social ramifications. So universities across the country are beginning to require computer science majors to take ethics in computer science courses. So before it was an elective that they could choose to take if they wanted to, if they were interested. And now these courses are specifically focused on issues around computer science. So universities like Cornell, MIT, Stanford, Harvard, the University of Texas are all among the colleges that have adopted these courses. And the questions posed to students are things like, is the technology fair? How do you make sure that the data is not biased? Should machines be judging humans in this case? And the new ethics courses cover things like artificial intelligence and autonomous machines, privacy and civil rights, and platforms like Facebook. But what about those of us who are already in the field? We're probably not going to go back and take ethics courses to figure these problems out, but we are working on these solutions. So there's even more great information that came out of the Data for Black Lives conference. These are questions to ask yourself when building fair algorithms. You should ask, who counts? Who is doing the counting? Who created the counting mechanism? Who is asking for this data and why? Who determines who is counted? Who determines data integrity? And who breaks the cycle of bad data and how? A lot of people talk about the pipeline in tech being broken, but I don't think it is broken. We have quite a bit of diversity already, but we need to do a better job of giving diverse voices agency to make a difference. It is undoubtedly true, though. Right now, most of these programs and softwares and algorithms are being built by cis white men predominantly. Radiat Abebe founded Black in AI. Black in AI started as a community organization where people, black people, could come together who may not have a chance to meet each other otherwise. They may be on teams where they're the only black person that they work with. So it's a place to bring them together so that they can form strong bonds and stay in the tech industry and feel safer. And so the goal is to diversify the field and increase the number of people who enter and stay in the field so that the people who ask the questions and set the objectives in building AI becomes more diverse. And thus the algorithms are trained on more diverse data and have less bias. So here's a great example of what happens when you do diversify your team. Pinterest launched a new feature on their site which allows for a search feature based on skin tone. Their idea behind this is basically that people looking for beauty tips need to find relevant hair and makeup advice that's specific to their race. So Pinterest said that the skin tone feature is a direct result of the diversity and inclusion efforts that the company has made. Pinterest is one of the first tech companies to not only publish annual diversity reports, but also set public hiring goals. What's more, Pinterest also reported that now after these efforts, their company is made up of 47% of women, and 30% of their technical roles are filled by women as well. So this makes it one of the most gender diverse companies in the tech industry, especially when you compare it to companies like Facebook or Apple or Google. So in fact, Pinterest's head of diversity and inclusion works hand in hand with the product and engineering teams to build more inclusive features on the site. And Pinterest made gains in inclusivity by actually having more diverse ranges of thought at the table when developing their algorithms. So now, of course, we have to put our IBM hats on here because IBM has responded to Joy's findings in a few different ways. In the case of the poor facial recognition scores, we went on to build the AI Fairness 360 toolkit. This toolkit is an open source library of metrics and algorithms to help you examine, report, and mitigate bias in your models. It includes metrics for data sets and machine learning models, explanations for the metrics, and then algorithms to actually mitigate the bias and change things. So it's a bit different than what's currently available in open source efforts because it focuses not just on bias mitigation, but also on metrics. It's a Python package that contains a set of algorithms by a broad community of researchers to control unwanted bias. And the site contains 3 tutorials that you can play with to learn a little bit more about the toolkit. One focused on credit scoring, another one on medical expenditures, and then another one on classifying facial images by gender. And we've provided a pretty interactive experience for you to play around. There's an intro to concepts and capabilities of the toolkit and guidance material that you can use to determine which metrics and algorithms work best in your specific use case. So when we're talking about fairness, it's a pretty difficult difficult term to define because it's multifaceted, it's dependent on context, it's affected by culture and social construct. So our toolkit is useful towards achieving justice in many situations, but it can't fully capture fairness all the time. This process really requires broad discussion with multiple stakeholders in your process, with input on the overall decision-making workflows. So the toolkit really only works for you if you have a problem that's very well defined that you want to solve. So with 70 plus metrics to choose from, it's difficult to decide where you should start. So the metrics are based on different definitions of fairness and grouped together in different ways. So there are some sort of key groupings that you could focus on to start. So the first one is individual versus group fairness, or both. So in group fairness, in its broadest sense, you're separating a population into groups defined by protected attributes and seeking for some statistical measure to find equality across those groups. And then individual fairness is looking for individuals to be treated similarly. So it's possible that you might need to account for both of these things at the same time, so we have different metrics to cover that as well. So when looking at group fairness, you might be looking at the data versus the model. These metrics fall into a class where you contend with the difference between measuring fairness at different points of the machine learning process. If you need to control your metrics while the data is being trained, you'd use one set of metrics. If you can only affect the change after the model is done running, then you'd use a different one. So another set of metrics in group fairness is the we're all equal versus what you see is what you get. So with the we're all equal set, you assume that all groups have similar abilities with respect to the task, while with the WYSIWYG set, you assume that your observations reflect reality. So if you use college admissions SAT scores as an example here. With the WYSIWYG worldview, it says that the scores correlate well with future success, and that there is a way to use the score to correctly compare abilities across all your applicants. But with the we're all equal worldview, you're looking at scores and saying that they may contain some structural biases, so there is a difference in scores across different groups, and this should not be mistaken for a change in ability. So the last set of metrics is in group fairness, is the ratios versus differences. So some of the metrics deal with the differences between the data sets you're using for your model, and some metrics set ratios that allow you to set fairness metrics. So what you decide to use really depends on your specific use case. So as an example from the ones that are just on the landing page of the website, the statistical parity difference is the difference of the available outcomes received by an unprivileged group compared to a privileged group. So now that we've talked about metrics, let's talk about the algorithms. So the bias mitigation algorithms here attempt to improve the fairness metrics by actually modifying your data or the learning algorithm or the actual outcomes. So part of your decision on which algorithm you can use is contingent on when you're able to intervene in the actual machine learning pipeline. So if you can modify the training data, you can use pre-processing algorithms. If you're able to change the learning algorithm, then in-processing can be used. If you can only treat the learned model as a black box without any ability to modify the training data or the learning algorithm, then only post-processing can be used. We definitely suggest that the earliest mediation you can do is the best because it gives the most flexibility and opportunity to correct bias as much as possible. And if possible, all the algorithms from permissible categories should be tested because the ultimate performance really depends on data set characteristics. So really, like, there's no one algorithm that's just like a magic wand that's going to fix all your problems. So as an example from the list of algorithms here, optimized preprocessing is used when 90% of your data set is male and 10% of your data set is female. So you would reassign 90% of the weight to the female side and 10% of the weight to the male side to bring equal parity between the two. So let's check out one of the demos that is available on the site. You can see that we've accessed the data set from the ProPublica recidivism scores, so you can actually play around with that data set and check it out. So I'm just going to run this in the browser just for simplicity, but we'll choose the first one here, and you'll see that there are two protected attributes that we're going to sort of dive a little bit more into. So the first one is sex, and the second one is race. So in the sex data set, the privileged class is female and unprivileged is male. So female prisoners are more likely to receive less jail time, and male prisoners are more likely to receive more. And in the race data set, part of the labeling, the privileged class is Caucasian and unprivileged is not Caucasian. So we'll just press next here and let the bias metrics run as they are right now, the way they're rated, the way they're weighted. And you can see, we'll just stick with statistical parity difference because I already talked about that one. There is a pretty significant negative bias in the attribute for sex, and also a negative bias in the attribute for race as well. So we can take a look at different algorithms, and we'll choose the reweighing one. So this rates the examples in each combination differently to ensure some fairness before classification is done. And then we'll run it again, and it'll show us the comparison between the two once it's done running. All right, so now you can see the bias for sex has gone almost to zero, negative 0.03. So that's still a negative bias, but not nearly as much as it was before. And then with race, it's actually gone into the positive a bit, so that's really good, 0.02. So we'll just pop back over into our slides. So yeah, everything you need to access this toolkit is available for you to use for free on GitHub. This is also how you would contribute to the project. So for example, when we launched the toolkit, we had 9 bias mitigation metrics, or I'm sorry, we had 9 algorithms, but within the first week, we had someone in the community contribute a 10th. So that was really wonderful, and we definitely encourage your contributions there. And if you want to get started and you want a little bit of hands-on help, or you want to talk to someone about the toolkit before you get going, we have a public Slack community that you can join, and the researchers and data scientists and developers, we're all in there to help you with getting started.
So now we're going to talk about another tool for combating bias, the model asset exchange. Transparency around the data that machine learning models are trained on can help us identify cognitive bias. But with open source deep learning models, you have the ability to see and contribute to the models that are processing the data. For example, our IBM Model Asset Exchange. So let's say you want to incorporate a deep learning model into your app, say for example, an image classification model. First, you need to find a model that fits your criteria, and then for example, if you search for this model, deep learning image classifier, you'll get 100,000 results on Google. And then you'll have to read through a couple hundred pages of research papers. Then you need to get the code for your model. Then you need to find an implementation and get the code for that implementation. And here's the code for just one implementation of the Resident 50 model in TensorFlow. So now that you have the model, if you work for a commercial organization, you're likely going to be restricted on what kind of licenses you can use, so you need to verify the license for the model. And then finally, you're ready to train the model. Now, a Tesla K80 GPU can only train on about 50 images a second, depending on what kind of model you're training on. And this might be okay for transfer learning, but for training a custom model from scratch, this could take weeks or months and can be very expensive. And you also need to find a framework that either you're an expert in or someone in your company knows to train the model on. So finally, your model's trained, and now you're ready to deploy it, but you need to figure out how to do this. You'll probably want to package it up and stick it on the server somewhere. Finally, now you're ready to consume your model. My team at IBM is working on simplifying this process so that you don't need to be a deep learning expert. With the Model Asset Exchange, all you need is Docker, and we have over 30 models that you can choose from. So you can go to the IBM Model Asset Exchange website, ibm.biz/model-exchange. And for this example, we'll use the image caption generator model. So on our website, for each of our models, there's a Docker run command. And like I said, if you have Docker installed, you literally just need this one command to have a model running locally. I wasn't sure how the Wi-Fi would be in here, so I already have this model cached. But if I didn't have it cached, it would take maybe a couple minutes to download, depending on your connection speed. I guess I didn't copy the first letter. So with this one command, the model will download and run locally. All right, now the model is running, and you can call the model with the REST API. We also added a Flask interface just to make it a little easier and nicer for demos, and that will run on localhost port 5000. And for this example, I have an example picture of an airplane we can use. Just a picture of a plane flying through the clouds. And the model returns a couple of predictions. An airplane is flying in the air with its landing gear down, an airplane flying in the air with the sky background, and an airplane is flying in the air with its wheels down. So those all look pretty accurate. We also have a web app that someone built on top of the Model Asset Exchange. Where'd it go? There we go. So I'll just need to allow cookies, and I can upload the same image file, or I'll try a different one, some kids playing soccer. And we get the same result, a group of young men playing a game of soccer. So the models available in the Model Asset Exchange range from audio classification to image segmentation models to natural language processing and are based on multiple open source deep learning frameworks. We have vetted the licenses of all the code included in the Model Asset Exchange to make sure it's enterprise friendly. It's important to mention that the Model Asset Exchange does not solve the problem of bias by itself. Our text sentiment classifier model, for example, has many of the same biases we showed earlier in the Google model. And we're working to fix this and hope to release an updated version of the model in the future. But the point is that by building open source models, we increase transparency, providing more opportunity for hidden biases to be uncovered. The Model Asset Exchange does not solve the problem of cognitive bias in machine learning as a whole, but it opens a door towards collaboration and innovation in this space. Hence, the importance of open source as the answer. Here are 2 links to help you get started with the Model Asset Exchange. The first link will take you to a list of all of our models on that website I just showed you. You can browse through the website and find out more about the models, the data sets that we're trained on, and the GitHub repositories containing all the code to deploy the models. The second link is the Model Asset Exchange Slack community. Please join and connect with us if you have any questions about the Model Asset Exchange.
So just announced recently, IBM released the Diversity in Faces dataset. IBM researchers have developed the diversity in faces dataset. It seeks to advance the fairness and accuracy in facial recognition technology. So it's the first of its kind available. It has over 1 million human facial images included in it. And the images actually come from a publicly available data set from the Creative Commons. So the data set provides a more balanced distribution of and broader coverage of facial images compared to previous data sets that were publicly available. And the insights we've discovered from the analysis of the 10 initial coding schemes on this data set have really increased our understanding of what is important in characterizing human faces and really enabled our researchers to continue important research into ways to improve facial recognition technology. So the dataset is available today for you to access, but admittedly it is a little hard to get. It's only available to researchers, and you have to give quite a lot of information to qualify to get it. Part of the reason for that is because it's not available for commercial use. And another reason is that while we were developing it, GDPR came out, and so we aren't able to identify who in the data set might be an EU citizen. So we don't want to violate GDPR by making it commercially available. But it's available for research, so anyone can utilize it to increase the accuracy of their facial recognition models. And IBM is really proud to make this available. Our goal is to help further collective research and contribute to creating AI systems that are more fair. So now remember, I talked earlier about the Gender Shades project. Recently, Bolin released an update to the project, retesting the previous systems that she'd examined and expanding her review to include Amazon's recognition and a new system from a company called Kairos. So there is some good news. She found that IBM, Face++, and Microsoft had all seen significant improvements in the accuracy of their gender classification for darker-skinned women. Microsoft reduced their error rate below 2%. But IBM, we did a little more than halve our rate in accuracy overall, but we still obviously have a far way to go in increasing or decreasing our rate of error. This is why we're really committed to committing all these resources to this issue. Bolin said that the study proved to the public basically that the need for these technologies to be held accountable externally is incredibly important towards making the whole system more fair. So you can actually volunteer your time for this fight for justice. Bolin founded the Algorithmic Justice League, and they have a sign-up form on their website where you can volunteer to test software and build inclusive training sets. They also have ways to report bias or submit your data sets to be checked for bias. She started this collective as a way to combat bias in machine learning. She's just really wonderful. I love the work that she's doing. I don't have any connection to her. I just wanted to, shout from the rooftops what she's doing. But in conclusion, we need to contend with the fact that data is generated based on human behavior, and algorithms are built by humans. So no matter what, as technology practitioners, it's our responsibility to build systems that are fair. And I really don't think that anyone who built any of the examples we showed earlier meant to cause any harm with the algorithms they built. But they did, and they do, and they continue to. And it's our responsibility to stop it. So whether this means making better decisions when building these tools, or pushing for legislation to protect our privacy or freedom, or working towards a more inclusive work environment to make more diverse voices at the table, we all have a role in this fight for justice. So before we end, I have one little plug from IBM that I wanted to make. Call for Code is a global competition that we have that's available. It's open right now. The top prize is $200,000. The projects are focused on helping to respond and recover from natural disasters. So please get involved if you're interested in jumping in. And you can go to the callforcode.org to get more information about it. But the contest is open now, so get going if you're interested. So thank you so much for your time. If you are interested in seeing my slides, or we also have a list of all the sources that we used in building this talk available in that bit.ly link, and you can access all that there. And thank you very much. Any questions for us?
Go ahead.
I was wondering if the AI bias mentioned something about pipeline. I was wondering if it's got any kind of wrapper or API similarities to like, scikit-learn, for example, so you can actually literally plug it into your pipeline.
So yeah, I'll just repeat the question since there is no mic out there. He asked if the AI Fairness 360 has a wrapper that's built with scikit-learn. Does that kind of,
This follows the API.
or follows the,
Be inserted as an actual pipeline object, for example.
yeah, or follows that pipeline, and it is it's not completely integrated with scikit-learn, but it is pretty comparable. So we can help you get started, but yeah. Any other questions?
So I'm assuming most of these cognitive biases request your relates to supervised. Is that fair?
I'm sorry, I'm gonna have a hard time hearing you.
Su-
Did you hear?
I'm assuming most of the cognitive biases addressed here relates to supervised learning data. Is there anything that you can provide in relation to unsupervised?
So the question was that all these examples we showed are about supervised learning, but do we have any examples of unsupervised learning biases? And
Or is there any way to mitigate that for unsupervised learning that is not relying on training?
I can't think of any examples or ways. The AI Fairness 360 toolkit may have some ways to mitigate bias in unsupervised learning. I'm not entirely sure. The toolkit really focuses more towards like a data pre-processing, your data set collection. So I'd imagine you probably could.
So it sounds like this is probably the problem best solved upstream with the data selection.
Yes, as far upstream as possible is where you want to solve the problem. You can solve it further downstream, but it seems to work much better the further upstream you solve it.
I had that slide where you said you solve it post-processing. Can you elaborate on how maybe address bias at the post-processing stage?
So bias post-processing, I'm not.
So there were three circles.
No, I understand. I'm not very familiar with how we do that. Maybe that's weighting individual results differently. Maureen, do you have more information about that?
Yeah, that was kind of my thought about it, was that just kind of like actually just reweighing the results, and but it doesn't really fix the problem of bias. It's just kind of slapping a Band-Aid on it. Yeah. Right, yeah. I mean, it's not much better than just having a human check it at that point. Right.
Any other questions? Well, thank you for coming.